Hello everyone. Today I'm going to be teaching you how to find the foci and the vertices of an ellipse. So right here we have an equation of an ellipse, which is x squared over 9 plus y squared over 8 equals 1. And now to make sure it's an equation of an ellipse, we can tell because it has denominators underneath the x and the y values. So we can tell it's not an equation of a circle. And we can also tell it's an ellipse and not a hyperbola because it has an addition sign rather than a subtraction sign. So right there we have an equation of an ellipse. And now we need the first step in determining the foci and vertices of an ellipse is to determine whether or not it is a horizontal or vertical ellipse. A horizontal ellipse is simply one that stretches out to the left and right on the x-axis, and a vertical ellipse is simply one that stretches up and down on the y-axis. And so to determine which one it is, we simply look at the two denominators. And so now we look at the two denominators and figure out which one is the greatest of the two. And as we can plainly see, 9 is greater than 8, so 9 is the greater denominator. Now, we look at which denominator, we look at 9 and we determine which variable is above it in the numerator. And because the x value is in the numerator, we know that the ellipse is going to be a horizontal ellipse. If the 9 were to be, the 9 were to be underneath the y value, we would know it's a vertical ellipse because it is on the denominator of the y value. But since it's the denominator of the x value, we know it's the horizontal ellipse. So we can just get rid of this guy. We don't really need him. And we're going to keep a horizontal ellipse on the screen just for reference, and we might make a couple of notes on it at some point. So now that we've determined that our equation is an ellipse and the kind of ellipse that it is, we can continue with finding the foci, and the vertices. So, the first step is that we're just going to make our equation of an ellipse a little bit easier to understand by writing it out as the actual equation of an ellipse. And so, the equation of an ellipse is x, or a horizontal ellipse for this matter, is x minus h squared, zoom in a bit, over a squared plus y minus k squared over b squared equals 1. So that's our equation of an ellipse. So looking at our actual equation of an ellipse, we can see that we have no h and no k values. One of the properties of an ellipse is that its h and its k values are equal to what the center of the ellipse is going to be. But since our equation doesn't have any, we know that our center is actually going to be at 0. Let's zoom in and make that look a little nicer. We know that our center is going to be at 0, 0. Simple as that. Now that we've determined our center, we can actually write out the equation into a form that will be a lot easier for us to figure out the numbers that we need. So we're going to plug in our values that we know. So we're going, I should do a different color than yellow. Sorry about that. Let's try purple. Purple's a nice color. So we know x minus 0 because h is going to be the x value of the center. Since it's at 0, we write 0. So x minus 0 squared over 9 or we can change it up a bit so that it's in the a squared form. So it would be 3 squared. I'll explain why I did that later on. It'll make it easier for us to find the vertices of the equation, but it wasn't totally necessary, but you'll thank me later. And now we can do the y minus 0, because k is the y value of the center, which is 0, squared over 8. Alright, so now that we have our much nicer and a slightly more organized version of the equation, we can actually start figuring things out. And now, let's move on to the vertices of an equation. So let's make this little box. This is going to be a vertices box. This is where we're going to figure out the vertices. So, the trick to finding the vertices of a horizontal ellipse is to have the points h plus or minus a, and then k for the y value. So looking back, we can see that a squared equals the denominator of the x value. And so as you can see, I changed that to 3 squared so that we can figure out what a is without having to work it out later. So now we know that a equals simply 3. So all we have to do for the vertices is plug it into this little vertice equation right here. So we get h plus or minus 3 for the x value and k for the y value. And since we know that h and k both equal 0, that makes the equation a lot easier. So we have simply 0. Let's take the eraser. Whoop, that's not the eraser. Take the eraser. Get rid of h and get rid of k. We don't really need you guys anymore, sorry. And we write 0 instead of h and k. So 0 plus or minus 3, we can get 3 for the x value and 0 for the y value, and negative 3 for the x value and 0 for the y value. Now these 2 points right here, these are the actual vertices of our ellipse. So we are halfway done. Let's write them down onto our little reference guide right here. So vertices, vertice over here, it's at point negative 3 and 0. And this is vertice right here, this lovely vertice right here, is at point 3 and 0. There we go, we're working out our ellipse. And now we just need to figure out our foci. So now, let's make another box just for our foci. Alright, foci are a lot like ellipses, not ellipses, are a lot like vertices, but slightly more complicated. The foci, what they are, is that they are 2 points, and make that smaller, are 2 points equal distance from the center of the ellipse. And what these 2 points are is that they act as a little interesting distance thing that can help determine how round an actual ellipse is. So let's say we were to find, let's pick 2 points on the outer side of the circle. So let's pick right here and right here. Now the trick to these foci right here is that if you were to measure distances from both of the foci to the points, you would get a number that would be equal to the distance between the foci and the other points. So these points right here, these distances right here between the points would be equal to each other. So that's what the foci act as. They kind of determine the roundness of the actual ellipse with that little trick right there. And so, to find the foci, it's a lot like the ellipses in that, not the ellipses, a lot like the vertex, sorry, I keep getting the two words confused, where we have h plus or minus c and for the x value and k for the y value. Now, if we look at our equation all the way up here, we don't see anything about a c value, and that's because we have to find it ourselves. The c value has a nice little equation that makes it very easy to find. It may look a little familiar to you because it looks a lot like the Pythagorean theorem, except we're not dealing with triangles, and this doesn't quite work with it works with ellipses, but it won't work with the hyperbolas, so don't get too confused. So c squared equals a squared over b squared. So simply all we need to do is we need to plug in the a squared and b squared values, which would be 9 and 8. Oh, I made a mistake. Okay, that's the Pythagorean theorem. This is not the equation for c squared. The actual equation for c squared is c squared equals a squared minus b squared. Alright, sorry about that. So now what we're going to do is that we're going to plug in our a squared and b squared values, which we can see are 9 and 8. So we're going to rewrite our little c squared equation, and we're going to get c squared equals 9 minus 8, which is pretty easy math. We get c squared equals 1, and if we square both sides, we get c equals 1. Very simple. So now we go back to our foci, and we just simply plug in 1 for c. And because we already know that h and k equal 0 because they're the center, we can just plug in that too. So 0 plus or minus 1 for the x value, and 0 for the y value. And with that, we get 2 points, which are going to be -1 for x value and 0 y, and +1 for x value and 0 y. And now these 2 points down here are actually the points of our foci. So if we return to our little representation of our ellipse, we can plug in our foci. So right here, this will be -1 and 0 for that foci, and this foci will be 1 and 0. Alrighty, so now we took the equation of an ellipse and we were able to figure out the vertices and the foci of the ellipse just with this equation. So there you go. I hope you enjoyed the video, and make sure you comment if you have any questions or anything. Thank you for watching.